Okay, we'll go ahead and get started with Chapter 1. The title of Chapter 1 is An Introduction to Statistical Thinking. And what we're going to do in Chapter 1 is present a variety of examples that are centered around fraud and discrimination. Before getting into our first example, I'll just present a personal experience that I had about a year and a half ago in this regard. And that was that my wife and I were traveling to Florida, and we had spent part of a day in and around Orlando, and we attempted to make a purchase with our Wells Fargo debit card. Now, this purchase was denied, which I found to be strange, but I went ahead and used a different card, made the purchase, got back in the car, and shortly thereafter Wells Fargo actually called me on my cell phone and asked whether or not I was in Florida and if I tried to use my debit card to make a purchase. Now, if we stop and think about this, what Wells Fargo had to do was identify that that particular transaction that I was making was an unusual transaction or was an uncommon transaction for me. So they needed to identify whether or not that was an outlier compared to the other types of transactions that I typically make. And in particular, geographically, most of my purchases are in and around southeastern Minnesota where I live. So they were able to successfully identify that my card was being used in Orlando, which was very unusual, and that's the reason why they denied that transaction. Now, we'll go ahead and get started with section 1.1, and that is the title of section 1.1 is Evaluating a Claim of Hearing Loss. In this particular example, we are going to be looking at insurance fraud, and this is the deafness example. Our first example is coming from the Journal of Consulting and Clinical Psychology, and the title of this article is A Forced Choice Technique to Evaluate Deafness in the Hysterical or Malingering Patient. Now, the term malingering means that somebody's just trying to fake an injury to their benefit. And in this particular example, we have a 27-year-old male with a history of multiple hospitalizations, and his past records indicated that he was manipulative and exaggerated his symptoms and was generally disruptive. He made repeated attempts to obtain compensation for his disabilities, and during his present hospitalization, he complained of hearing loss, left side weakness, memory deficit, etc. Now, we are going to evaluate or attempt to evaluate his alleged hearing loss. Now, in the most common way of doing a hearing test is simply to put headphones on an individual and play a sound off the left side, and if they can hear the sound in their left ear, they're supposed to raise their left arm, and then they play a sound off of the right side, and if they can hear that in their right ear, they would raise their right arm. Now, this particular test is pretty easy to beat if somebody is trying to fake their hearing loss, because all they need to do is just simply not raise their hand anytime. They never have to raise their hand. They just pretend that they don't hear anything, so they wouldn't raise either hand on each instance of them playing a sound. So they had to come up with something a little bit better than just your standard hearing test. And what they did is they created a screen in which there was two lights. There was a red light and then there was a blue light. And when the red light would turn on for 2 seconds, and then it would turn off, and then the blue light would turn on for 2 seconds and it would turn off. And the people doing this test decided to play a sound when one of those two lights were on. Okay, so maybe the red light is turned on and then a sound is played, and then the red light would turn off, the blue light would turn on, but there would be no sound played in that instance because it was played when the red light was on. And likewise, they might turn on the red light with no sound. They would wait 2 seconds and then they would turn on the blue light, and then the sound would be played with the blue light in that situation. Now, if a hearing person were to take this test, okay, and let's suppose that they actually did 20 trials of this test, So we're just using 20 here as an example. In this particular paper, in the real situation, they actually used 100, but we'll go ahead and just use 20 for now, and we will come back to the example where they used 100 trials at the end of this video. So let's suppose that they had done 20 trials. Now, if you and I were taking this test and we have the ability to hear, then we should be able to correctly identify what light was on for each of those trials. So the number of times that I was able to correctly identify the light with the sound being played would be 20 out of 20. So a hearing person would be able to identify every situation, or every time would be able to identify the correct light that was on when the sound was played. And I shouldn't get any of those wrong. So we're going to call that situation A. Situation B would be a situation where they get about half of them right and half of them wrong. Okay. Now, because there were two outcomes, okay, there's two outcomes here. Somebody, even a deaf person, right, even though they can't hear, is going to be able to get about half of those correct, because they have to make a choice between either the red bulb or the blue bulb, and we know the sound is going to be played with one of those two. So a deaf person is indeed going to get some of those correct, and in fact a deaf person, just by guessing, is going to get about half of those correct. So situation B, where somebody gets about half of them correct and half of those wrong, would actually represent a situation in which somebody cannot hear. So let's go ahead and take a moment and just answer these questions that we have on the bottom of page 2. What can be said about an individual whose outcomes are similar to situation A? Well, what we said there is situation A implies that this means that the person can hear. A hearing person should be able to get all correct. And what did we say about situation B? Situation B is a situation where somebody, well, that they were guessing, that the individual was guessing, or in this particular instance, that the individual cannot hear, because if they cannot hear, they're going to have to make a guess at either the red light or the blue light. Now, these examples are called forced choice examples, so they have to make a choice between the red light and the blue light. We're not allowing somebody to just put their hands up and say, I don't know. They have to make a choice between the red light and the blue light. Now, so if somebody scores really high on this, okay, so let's suppose somebody is way up here, then what that means is that that person can hear. Okay, and so they should be on the upper end of this number of correct. They should be able to get most of those correct. And in fact, if they hear very well, they should be able to get all of them correct and be 20 out of 20 here. So this up here is situation A that we described up above. Now, a deaf person is actually going to be near the middle here. So somebody that is deaf is going to be in the middle here and should be around, say, 10. Maybe if they're guessing, then maybe 9 would be okay. 11 would be okay. But that's where outcomes should be for deaf people. So if I just grab let's go ahead and grab this and just bring this up and say, okay, so this is kind of the area for which I would expect deaf people to be. Now, one thing that we haven't talked about is there's certainly going to be some variation in what deaf people are going to get for the number of correct. Because if they're not a very good guesser, they might get only 9 correct or 8 correct. Or if they're better than an average guesser, then maybe they get 13 correct. But certainly I wouldn't expect a deaf person to get all of those correct. If they're way up here, then that's going to indicate that somebody can indeed hear. Now, the other end of the number line is one that we have not looked at yet, and that would be what happens when we're way down here on the bottom side. So if we're way down here on the bottom side, what that's going to actually indicate is that they can indeed hear, but they're lying about their ability to hear. So they're trying to purposely throw us off if they score too low on the number of correct here. Okay, so that's the situation. What I identified down here is situation C. Situation C is the number of times an individual is able to correctly associate the light with playing a sound. So they were never able to get any correct, and they were wrong every single time, which again would indicate that somebody's trying to throw us off and not they can actually hear, but they're just trying to throw us off. Now, one thing that we have to do if we're trying to identify whether or not somebody's lying to us is we need to understand kind of what the range is for deaf people. So what is a reasonable number of correct for somebody that is deaf? We said that 10 should kind of be where they're at because there's two outcomes again. There's a 50-50 chance for each outcome. If there's 20 trials and there's a half a chance of getting each trial correct, then that would be again centered right around 10 here. There's going to be drift to the left and to the right of that, but how much drift we don't know yet. Now, we need to be able to identify that drift in order to figure out what a likely outcome is for deaf people versus what an unlikely outcome is for deaf people. So this becomes an interesting statistical problem in trying to identify where is the cutoff for where we expect deaf people to end, and then also where we would expect lying people to be at as well. Now we need to think a little bit about this. If somebody is going to lie, they're probably not going to get all of the guesses wrong. Okay, that's going to throw a red flag in itself. So what they might try to do is purposely get some of those correct, just to try to keep us off guard. For example, if I had all the answers to a quiz, and I was taking a class, I had all the answers to the quiz, I might not get all of them correct. I might go ahead and get a couple of them wrong to try to throw the teacher off from thinking that, okay, I don't really have the answers. If I got all of them correct, that might raise a red flag. In the same sense here, if I don't get any correct, that might throw a red flag. So somebody's probably going to, at least if they're smart about it, is probably going to try to drift off of getting them all incorrect. So they might try to get some of them right to try to fool us. So what that means is that that lying area actually probably drifts up a little bit. Okay, not just at 0, but there's certainly, if they're trying to throw us off, they may drift up a little bit. So again, what we have to do here is decide what is an unlikely outcome for a deaf person. Okay, is it at 5? Is 5 kind of the lowest that we would expect? Or is it 6? Is 6 kind of the lowest that we would expect? Okay, or is it 7? Is 7 kind of the lowest that I would expect? If 7 is the lowest that I would expect, then I can bring my lying region up further. On the other hand, if the likely outcomes for deaf people go all the way down to 4, then I'm going to have to slide my lying region back a little bit. Now, if they go, I've been talking a lot about the left-hand side here, so they could slide all the way down to 4, which would mean they would slide all the way up to about 16 as well. Okay, so there's some symmetry that's going on here. Now, I'm worried about the left side of this because I'm trying to identify whether or not this individual was lying. And lying is on the left-hand side. If I was up here, okay, that's not lying. Up here on the right-hand side is when they get all of those correct, and that's when they can hear. So on this particular example, I'm worried about what's going on the left side. All right, so how can I model these deaf outcomes? We can use a simulation model, which we will construct, to mimic the outcomes of a deaf person. Remember, a deaf person just has to guess at this, and I can get a computer to guess. This model requires the identification of two pieces of information. The first is the number of trials have to be identified. In this particular case, that was 20. And then the likelihood or chance of obtaining a correct response. And in this particular case, this was a 50% chance of obtaining a correct response. Now, what we are trying to model here is deaf people. Okay? So if a person is deaf, then I know that they'll have a 50% chance of obtaining the correct response. All right, so we have to identify those two pieces of information when we're trying to build a model or trying to get this done in a computer. All right, let's go ahead and talk a little bit about page 4. This quantity 10 that we talked about that a little bit. That quantity there is called the expected outcome. Now, the expected outcome is the outcome which is identified to be most likely. Now, in this particular case, to figure out the expected outcome, all I need to do is to obtain the number of trials, which is 20, and then that other quantity that I need, which is the probability of getting a correct response. And again, we're doing that under a deaf situation. So we're trying to build a simulation model for deaf people. Okay? So the expected value here for this particular example would be 10. All I need to do to figure that out is just, again, multiply 20 times 1/2. Now, that's what we would expect a deaf person to obtain. But as we said above, there's some inherent variation that we would expect for deaf people. The key here is to identify how much inherent variation. All right, so we're going to have kind of a pyramid-shaped what we call distribution or pattern that we expect to, and that we anticipate coming out of these simulation models. If we don't have much inherent variation, so in other words, deaf people, we expect them to be at 10 here, right down the middle, but they might drift down to 9 or up to 11. Well, that's not very much inherent variation in guessing there. If they drift down to 10 and up to 12, okay, so that's down 2 and up 2, that's a little bit more inherent variation that we might expect. And what we need to do with a statistical model or a simulation model is to identify how much inherent variation exists. Okay, for example, if we're on this one right here, then I would not expect a deaf person to get below 6 correct. And hence, lying people would be down here at 5 or below. On the other hand, if deaf people actually go from 10 clear down to 2, which would be -8, and then 10 clear up to 18, which would be +8, and that's quite a bit of inherent variation. So in other words, lying people would be real tight down here at just a 0 or a 1. Okay, so our model, basically the purpose of our model is to identify how much inherent variation exists in these repeated outcomes from deaf people. Again, we need to determine whether or not this individual, the individual that's being studied, whether or not that person is an outlier against what outcomes we'd expect from deaf people. I'm going to go ahead and skip page 5. What page 5 is about is just identifying that this can be done. Obtaining this simulation model can be done actually flipping coins, because a coin, right, has a 50-50 chance of either being heads or tails, and that's the same situation that we're at, that an individual has a 50-50 chance of getting the light correctly identified or not correctly identified. Okay, so we'll go ahead and skip page 5. All right. So now we're down onto our app. Okay. So what the app is going to do here, let's go ahead up here, and looks like I got an extra space. I'm just going to get that out of there so this matches what you guys have in your notes. All right. So now I'm on page 6. And what page 6 is about is I've actually created an app here at this location. And this is going to be on our website as well. It'll be a link there on the website as well that allows us to go ahead and participate in this hearing experiment as if we were deaf. Okay, so I'm going to go ahead and go to that app. We'll do that now. Okay, and this particular app is again set up to mimic what that particular individual, the same test that particular individual participated in. So again, in this simulation, a red light will be displayed, followed by a blue light, and a ringing sound will play with either the red light or the blue light. Now, if we go ahead and play this, if I have my speaker turned on, which I do, you could, not sure if you heard that, but the sound was actually being played with the blue light in that particular instance. Okay, and you can show the result here, and it tells me, yep, the sound was being played with that blue light. And I can run another trial if I wanted. Okay, this time the sound was being played with the red light. Again, I'm not sure if you heard that, but the sound was played with the red light, and when the blue light was on, there was nothing. So, okay, so again, if I participate in this hearing test, I should be able to get each one of these correct because I can hear what's going on. Now, the reason I like to start with this example is because we can actually participate and do this hearing test as if we were deaf. Again, the simulation model is trying to mimic the outcomes of deaf people. And all I need to do to mimic deaf people is just put my speaker on mute. Okay, so now I'm not going to be able to hear any sound coming out of my computer. So let's go ahead and run another trial. And at this point, because I have my speaker on mute, I'm not going to be able to know what light was on when the sound was being played. And again, this is what deaf people experience when they would be doing this hearing test. So I'm just going to have to guess, and I'm going to guess that it was the red light. Okay. Oh, and I was wrong. It was in fact the blue light that was on when the sound was being played. Okay. So, and we can do this over and over and over again. So that was just one trial, right? That was the first trial. And we can do this again if we wanted to run a second trial. Again, experiencing that as a deaf person. And this time I'm going to say that the blue light was on when the sound was being played. Again, my speaker's on mute, so I don't really know. Oh, look at there, I got it right. Okay, so even though I had my speaker on mute, I was able to guess that one correctly. Again, I have two outcomes here, and each outcome is a 50-50 example. All right, so now what I want you to do is go ahead and push pause here on the video. Go to that app, okay, and then just go ahead and run this run that app a total of 20 times. Okay, with, again, I want, you should mute the speakers on your computer because I'm trying to mimic what deaf people are hearing. Okay, so go ahead and run the app, make a guess, and then determine whether or not you're correct or incorrect. And I will see you back in a couple of minutes. Okay, welcome back. I went ahead and ran my 20 outcomes. Okay, so I ran 20 as well. And here are the outcomes that I got. So on my first one, I was incorrect. But my second guess, I was correct. That was the blue light. I got the third guess correct as well. I got the fifth one correct. Looks like I got some stuff left over here. I got the fifth one correct. I got the sixth one correct. I got the that's not going to work very well. So let me go ahead and take those things off. So again, which ones did I get correct here? I got the second one correct. Let's go ahead and see if I can put in just trying to figure out, there we go, we could do something like that. I'll just put a yes in there for me, make that a little bit larger. Okay, so I got this one correct. I actually didn't get the first one correct, did I? I got the second one correct. I got the third one correct. I got the fifth one correct. Got the sixth one correct. I got the ninth one correct. The 11th trial was correct for me. And then 13 and 14 were correct. 15, I was on a roll there. 17, and then 20 was correct as well. Okay, so now what I want to do is, out of my 20 trials, how many did I actually get correct? So there was 1, 2, 3, 4, 5, and then on this side I got 6, 7, 8, 9, 10, 11. So the number correct that I actually got was 11. Okay, and again, I'm maybe just a little bit better than what I would expect to get. Without being able to hear, I should have got 10, so I actually got it just a slightly better than what I expect. Okay? Now, what I want you to do is go ahead and put your outcome that you got, so not the 11 that I got, but you go ahead and tell me how many correct you got and add it to the dot plot that we have down here. Now, this dot plot already has outcomes from 24 other students, and we just want to add okay, let's go ahead and add your dot to that dot plot. And in particular, mine would be at 11, right? So let me go ahead and see if I can do this. I'm going to add 11 to my dot plot. Well, it's not working the best, but add 11 to my dot plot. And then I want you to just take a minute to answer these questions down below here. Okay. All right. So I'm having trouble getting that dot there at 11, but that's where it would be. Okay, so let's go ahead and just hit pause and see if we can take some time to answer these questions down below. I'll come back here in a minute and go through the answers as well. So go ahead and try to answer questions 4, 5, and 6 here on page 7 of the notes. Okay, well, welcome back. So circle your dot on the plot above. Again, I had a dot. My value was an 11 here, so we'll just go ahead and highlight that. All right. How many correct did you get? Well, that was 11. And again, go ahead, and yours might be different than that because we all did these just a random selection there. How many would we expect you to get correct? Well, again, it's 10. The expected value is 10 when mimicking a deaf person, right? Okay, or when we have to, when we're guessing. Okay. How many could you have gotten correct? We could have got 20 correct, so could have gotten all 20 correct. Now again, for a deaf person, when we're mimicking a deaf person, that's going to be probably an unlikely outcome. We wouldn't anticipate a deaf person to get all 20 correct. Is your dot, which is 11, similar to the other 24 students? So yeah, it's actually my particular dot here was at 11. It's quite common. There's also quite a few dots at 10 there. They actually drift. Some students actually got 15 correct. Again, these are pretty good guessers, all right, because what we're trying to mimic here is deaf people. And then on the left side, we have some people that weren't very good guessers. They're down as low as 5, I guess. There is kind of the lowest that we would expect here from this particular distribution or this particular graph. Okay, so yes, my outcome of 11 is common compared to the other students. Okay, so how about question 5? Which of the following is true about these dots? A, these dots are meant to mimic the outcomes of deaf people, or B, these dots are meant to mimic the outcomes of people who are thought to be lying about their ability to hear. Now you're going to see this question a variety of times, I guess, throughout the examples that we're going to do here in chapter 1, because and I've made a point of it here quite heavily that these dots actually are going to mimic deaf people. What we actually do is we statisticians kind of cop out when it comes to doing these, when we're doing these simulation or these simulated models. In some sense, it's really easy to mimic the outcomes of deaf people. We just need the computer to guess between one or two choices here. So the correct answer here is A, not B. So we'll go ahead and bold that just because that's the correct one there. Now, this is going to get confusing because what I'm trying to do is identify whether or not somebody's lying. Okay? But what we do is we don't actually mimic that individual. What we do instead is we mimic the outcomes of deaf people. Okay? Again, trying to find kind of that lower edge there. And we're going to use that then to determine whether or not the outcome from this particular person is beyond that, is uncommon against deaf people. Now, again, that process, doing it that way, is much easier than trying to mimic the outcomes of a lying person, because we don't know how good of a liar they are. If they're really a bad liar, then they're going to be tight down here at 0. They're going to get all of them incorrect. But if they're really good at fooling us, well, actually, if they're really good at fooling us, they'll be in here at 10 or 9 or 11. All right? But again, it's much easier to model. It's much more, it's easier and it's more fair, I guess. It's simpler to model the deaf people because we know that deaf people just have to guess. And we don't have to worry about to what degree is that individual good at lying or not lying. Okay, so again, we kind of cop out there. And that's number 5. So given the simulation results in the above plot, what do you think about a subject's claim if they have 7 correct? So let's go back up and look at our graph. Okay, 7 correct is actually right within the realm of deaf people. Okay, so 7 is in the realm of deaf people. So if somebody got 7 out of 20 correct, I'd consider them to be deaf. Now, what if they got 0 or 1 correct? Okay, so let's go back up here and look at that a minute. Now, 0 or 1, 0 or 1 never happened. We never got anybody. Okay, none of our deaf people, which was actually just 25 different students, okay, with their speaker on mute, so they're mimicking deaf people. Out of those 25 trials, we never saw anybody down here at 0 or 1. So if somebody was down here at 0 or 1, I would anticipate that, yes, indeed, that they are lying. Okay, so if someone got this low, we would expect that they cannot hear. Why? Because they are below the outcomes, the 25 outcomes, right, from deaf people. So they're way lower than what I would expect a deaf person to get. Now, how about 2, 3, or 4 correct? Okay, so let's talk a little bit about 2, 3, or 4 correct. 2, 3, or 4 correct is getting closer to the deaf people. Okay, that's that kind of difficult spot. There's kind of a gray area in here, all right, where this edge is at. 2, 3, and 4 still is beyond or below what I would expect for deaf people, but it's not to the same degree as 0 or 1. Okay, so if somebody got a 2, 3, or 4, again, I would say that they are likely to be lying. All right. Again, 2, 3, and 4 are below the outcomes, that I would expect for deaf people. Okay? I'll just reiterate one more time. I'm not worried about what's going on the upper end of that distribution. Okay? I'm not worried about what's going on here because I'm trying to identify whether or not somebody is lying. All right, so that's why I'm on that other end of the distribution. All right, page 8. Well, page 8 is pretty easy. Page 8 is actually just the outcomes from the actual study that was done in that article. And what they actually did with that individual is they had him not do 20 trials, but they had him do 100 trials instead. Okay, well, this means that that number line is actually going to stretch. It actually could go all the way down to 0 here, and it could stretch all the way up to 100. So the number line goes from 0 up to 100. If the individual did 100 trials, and again there's a 50-50 chance of getting those correct, we would anticipate that most of the dots are going to be around 50. Again, we're trying to build the distribution or the pattern for deaf people. And deaf people are going to have to guess. 50-50 situation, 100 trials, so the expected value is going to be 50. Now, the amount of inherent variation that I can expect when I do 100 trials, okay, goes from about, 50 down to about 40 here. So it goes down about 10. It also looks like it goes up about 10. Again, this is outcomes for deaf people. Now, this particular individual actually got 36 out of the 100 correct. Now, this is kind of interesting because they're not even close to 0, right? So you might think, well, 36 is pretty close to 50. So maybe that individual can indeed hear. Or excuse me, maybe this individual is indeed deaf. Okay, 36 to 50 is what, 14 away? But 36 to 0, that's 36 away. So this dot here is actually somewhat closer to the expected outcome than it is at 0. However, the conclusion that I would arrive at is that this individual is actually a really good liar. They were trying to get some of them correct so that they would not be indicated as being unusual. However, this individual did not go far enough. Okay? In his ability to try to lie, he didn't correct himself enough. If he corrected himself enough, I would expect, if he was actually deaf, I'd expect him to be kind of between 40 and 60. All right, and this individual falls outside of that realm. Okay, so again, the subject gave a correct answer of 36 out of 100. What do you think about the subject's claim that he suffers from hearing loss? I think he is lying. Deaf people range from 40 up to 60. And this person is below what I would expect for a deaf person. So I'm going to indicate that that individual, or at least statistically speaking, I'm going to say that that individual is probably lying. Okay, I'll skip number 8. How about question number 9? Your friend makes the following statement. This subject got too few correct in his hearing test. So obviously, this person suffers from complete hearing loss. Why is this statement incorrect? Well, this statement is incorrect because a deaf person, in the way that this was constructed, a deaf person would actually have the ability to get some of these correct. So a deaf person will get about 50% of the outcomes correct. Okay? A deaf person isn't going to get 0 correct. A deaf person is going to get about 50% of the outcomes correct. So the expected outcome for deaf people is 50. All right? A value close to 0 would imply that the individual is lying about their ability to hear. All right. Well, that completes section 1.1. That was our first example that we went through. We investigated the likelihood that an individual was trying to commit fraud in their ability to hear. And what we ended up concluding was that this individual did, or was likely not being truthful in their ability to hear. All right, in the next section, we'll go through some additional examples that will be centered around something similar. All right.